All right, so U substitution, you don't use it all the time. You use it in an integral when you really have a kind of two functions in one. It is literally the chain rule of derivatives backwards. So one of the things that people were questioning as we went through this is sometimes you would have to use U substitution, sometimes you wouldn't, and like when do you know when you have to use it or not? So I kind of always said, well, one rule of thumb is if you sort of have two types of functions going on, then you probably need to use U substitution. So this cube is one type of function on its own. So if I just ask you to integrate x cubed, that would be okay. That's just a regular add 1 to the power and divide by that. So that would be x to the fourth divided by 4 plus c, and we're good to go. And cosine is its own function. So if I just asked you to integrate cosine of x, that also, okay, well, we know what that is. That's sine x. And so those two pieces there individually, no U substitution is needed. I have a rule that applies to them individually. But when I start to overlap them or make composition of functions, or like this cosine x is being cubed, that's when we know we probably have a chain rule. So I'm just going to first rewrite this, because really what this means is I have the integral of, and I'm going to put cosine x in parentheses, because this the way we're looking at it with this 3 there is a shorthand way of writing this. And sometimes it's easier to see the trig functions when they are have the cube on the outside of the parentheses like that. So now the question is, okay, I see I have something being cubed and I've got a cosine. This one even has another thing going on. It's a sine, but notice that the sine is not the thing that has the extra function happening to it. The sine is just sitting out here on its own. Also notice that sine and cosine are derivatives of each other. So when you do use substitution, one of the extra things that will be in there is often a derivative of one of the functions that's being created by the composition of functions. So to create the composition of functions, you want to create u to be the function that is the innermost function. So in this case, this is inside of a cube. So this is the inside function of my composition of functions. So I'm going to make cosine of x equal u. And I'm just going to start substituting things as I go, because it is called U substitution. So if this is what I'm going to call U, then I can start to rewrite this integral. And this is now U cubed. And just a minute ago, we talked about how that right there is not too horrible of a thing to deal with. The problem is there's this times sine x, and we know that we don't have a product rule for integration, so I am not done yet. And so what we do with U substitution is we find what our U is going to be, and then we take the derivative of that. So if U is cosine du, and really when we find the derivative, we are finding the derivative of U with respect to x. So this is a very important notational piece that's going to help clear this thing out. So whenever we found the derivatives, a lot of times we would just write like u prime or y prime, but really what we're doing is du dx. So remember, u prime and du dx both mean the same thing. They're both just indicating that I just found the derivative of u. Well, the derivative of cosine is actually negative sine. So I meant to change colors here, negative sine. And so I now sort of can see where this thing is able to maybe be substituted right there. The problem is I got this extra negative sign here. So there's a couple ways to think about this. I'm going to show you sort of a full-blown true substitution method that seemed to work for quite a few people. So first, whatever we make u in here, we've got to substitute the u in. Now I want to get rid of this dx, because I really want to get rid of everything that's an x. So what I'm going to do is I'm going to multiply this dx over to here. So I can do that. That's a quick move. And that dx would multiply to this side of the equation. And I want to get rid of dx, so I need dx by itself. So now I'm going to divide both sides by sine of x. So if I do that, and I'm going to rewrite this over here, dx would equal, and I would divide this away. So it's gone, and I would have to put it under here. So dx would equal du over negative sine x. And now I have something that I can substitute. This is what dx equals. And I know it's kind of getting a little messier here, but that's all right. So I'm going to rewrite. I'm going to try to keep my color coding. This is still u to the third. Boom. Notice I'm not doing anything to the outside function. I am going to keep my sine x right here. And now I'm going to get rid of dx because this expression is equal to du over negative sine x. And what happens if you do it this way, and it will happen if because I can't have two letters in here, I need to only have u's. If I'm doing u substitution, I can have no x's. Notice that this sine x and this sine x will cancel, so that would be gone. This would be gone. There is a negative, that's okay. I can put that negative out in front because it's just like a -1 here now and it doesn't do anything to me. So if this had been like a 4 or an 8 down here, I would just move it out front and be like 1 over 8 or whatever you end up with as terms of a constant, a number, no variables, I can pop it out in front. And then I am just integrating u cubed du. Now the du is also what messed people up because when we integrate, even up here when I did that example with just integrating x cubed, then when you integrate this differential piece, basically dissolves up into this, just like when you, before you had a derivative, you didn't have this piece, like when I was here, I didn't have a du. Oh, now I have a du. It shows up because you find the derivative. Well, when I go backwards from having a derivative to not having a derivative, the du basically goes back and becomes a regular u. So this part here just kind of washes away. So the negative sits in front. Integral of u cubed is my regular power rule. I add 1. That becomes a 4 divided by 4. The du dissolved into this u, so I don't have to worry about that, plus c. And my last step is to come back and go, oh, well, this is what u is equal to. U is equal to cosine, so I can re-substitute that cosine in place of that u. So this would be negative, and I'll put it in parentheses again to start with the 4 up there, all over 4 plus c. Or you could write that as negative cosine to the 4th x over 4 plus c, or you could put a 1/4 out in front, it doesn't matter, but there you go. That was u substitution. So it's a couple things. You figure out what your u is, which is the inside function, then you have to take its derivative, which is du dx, and really what we do when you get that du dx is whatever is over here and the dx, they basically trade places. So that's what happened. This dx came over here, the negative sign went underneath, and you do a secondary substitution for dx, and then whatever is extraneous in terms of a function, an extra function, should cancel. And if there's a leftover constant, a number, integer, a negative, you can move those outside in front of your integral, and then you just do your regular integral rules. All right, it is a complex topic. It is a little confusing. See if that helps. And if it does not, you must let me know, and I will get you some more helpful hints. All right, there you go.